Geometric sequence. Now, in particular question that has to do with sequence, the big question in your exam, are kind of one of the most difficult. But let's have a look at this particular one. A weight is placed on a horizontal table with a vertical wall at either end. And we can see wall and wall. And that is the weight. A spring is attached to each of the walls, and we can see that, that's where it is attached, and to the weight, as shown below. The points A and B are marked on the table, and then the length from A to B is 120 centimeters. So in an experiment, the weight is brought to the point A. So we take that weight and we bring it here, and then released. So we can understand it will, if it is brought here, then it will go in this direction. It travels back and forth between A and B in stages, so that in each stage it travels 4/5 of the distance it had traveled in the previous stage, and in the opposite direction. The first 3 stages are. Now, before we read that, because very often it's difficult to understand or imagine what you are reading, how does it look like? Now, I'm going to have an attempt of trying to explain that to you. I know that the quality of this is not great, but let's just consider. So we can see this is the wall here, this is the wall here, and that's where our block is brought here. That's my point A. So what happened here is that this spring is very tight, isn't it? And this one, as you can see, it is very loose. So what happened when the spring is so tight? It has a force, isn't it? And with that force, once we release that block, that spring with its force is going to push this block and all the way here to that point B. So what happened? This spring gets really kind of long and then here is really, really squashed. So again, that spring here, because it's really, really squashed, it has a force and therefore it will push back. So that's the reason why we're going to have our weight here in the next stage. Now, however, it will not be able to push it all the way to point A. It will only push almost to point A. And then again, this spring now is not as squashed as here, so it doesn't have that much force, but it has still pretty much force, so therefore it will push it back. But because it's not as squashed here, therefore it will not reach point B, that is here. It will go from the point where it was to some distance before B. And then again, that one here is not as squashed, so it's going to push it, but a lesser distance than the previous one. So that is the idea that we are dealing here with. And we can understand that every time, because that spring is not as squashed, it's not going to have as big force to push it that far. Every time that distance is going to be less. And that's what the description is here. So the first travel distance, 120, but then from B, so in this stage, it doesn't travel the full distance of 120, but only 4/5 of that distance. And then again, in the next stage, 4/5. So every time I'm taking the previous distance and I am only getting 4/5 of that, meaning what? Multiplying by 4/5. So what does that mean? That is our geometric sequence. When we multiply every time, that's how we have geometric sequence. And here we can see there is actually a graph given to us. So first traveling 120, but oops, didn't want to do that. But then from B, from that point B, it doesn't go all the way to point A. It goes to new point C. And then from that point, that's where it stops, travel again, and it doesn't go all the way to point B, goes to new point D. So that's the idea that they are presenting. And we understand that with every time, the distance is going to be less and less. So what do we need to do? we need to complete the table. So we understand 120 first time, and we understand that the way this sequence is created, every time we multiply by 4 over 5. So that's basically is we put our numbers in calculator. So 96 multiply by 4 over 5. Now here we are told that we have to give it as a fraction if it is not a whole number. So 384 over 5, and again multiplying that by 4 over 5, we're going to get 1536 over 25. So those are our values. Now, I just want to point out a few things when it comes to question with geometric sequence. If you look at your table, let's just open our table to where we have formulas for the sequence. Those are the formulas for geometric sequence. And therefore, very often, our question is about those formulas. But we need to understand what are those formulas in the context of this particular question. What do they represent? So that is the term. So in this case, what is the term? This is the term. What does this value represent? This is the distance traveled every time. Okay, so this is distance travel. Now, what is Sn? That is a sum of what? Of the distance traveled. We are adding. So if I was to give the distance traveled for the first 4 times, what I will do, I will add them. So that way, the number I'm going to get, I will get the total distance that is traveled in the first 4 stages, isn't it? And then we have sum to infinity, taking into consideration that that block will keep on moving all the time. So that's what it is. That's the idea in the context of this question. So we kind of have to always understand that. Now, usually in your question, the way your question is structured, that normally the first question will be about Tn, will be about a specific term, and then the other one, the following one will be about the sum. How do I know when it is a sum? Usually the word total. Once that word total is used, then I can understand, oh, this is the sum, because that's what it means. The total value of whatever, in this case, distance, is when we add them. Okay, let's have a look at next part in the next video.